Another method that we can use sometimes is called the addition method. And addition means is we're going to eliminate a variable by combining or adding the two equations. So just as for example here, look at this simple equation or the simple system that I have. The process will be is I want to look for a particular variable that when I add them, it's eliminated. So notice if I added these, 3x plus a negative 3x, the x's are eliminated. I would have a negative 2y. If I were to add the y's, then adding the constants, I would have a 4. Solving that, I get a y equals a negative 2. Now I take this value and I would back substitute it into my original 2 by 2 or one of my 2 by 2s. Solve that, so let's just plug it into this one. So that would be a negative 3x plus a 2 times a negative 2 equals a negative 7. Work that out. And it looks like I get an x as a positive 1, so my solution would be the value or the coordinate point 1 and 2. So that's a little bit of an idea what the addition method will look like. So let's look at another example that will kind of build on this idea and help us develop the tools that we need to develop. So let's have a 3x. So let's write my system. 3x plus 2y equals 48. And 9x minus 8y equals minus 24. So there's my system. In order to use the addition method, I want to find out, can I add these so that the variable drops out? Well, if I added them right now, none of the variables are eliminated. So I need to use some of my rules of algebra to figure out how can I modify one of those equations such that that would drop out. So what if I multiplied the first equation by a 4 to both sides? And I'll just put like a little bit of a 4 in front of that first one as a little bit of an indicator to me what would happen. So let's do that. Let's use that 4 and multiply both sides of the equation by that value. So let's rewrite my system. 4 times a 3x, 12x. 4 times a 2y is an 8y. 4 times 48, that's 200 minus 8, so 192. Now, I didn't do anything really fancy there. I know I just left a 4 there, but basically I multiplied 4 to both sides of the equation because that's what we can do. What do we do to one side? As long as you do to the other. I just put a 4 as a notation to help me remember what I was doing. Let's write down the next line. Notice now I have a system. It's the same system but modified, but the same system. So now that if I were to add the two lines together, the two equations, a variable would drop out. 12 plus 9 produces a 21x equals 168. Let's double check that. That looks correct. Solve that, divide both sides by 21. X equals 8. So there's my value. What do I do with that value? Well, we take that value and we back substitute it into either here or here. One of my 2 by 2s, whatever one that looks the easiest to do. And to me, the easiest one right here looks like this very first one to begin with. So we would take 3 times this x, which we discovered or learned was an 8, and solve for that y. And I get a value of 12. My solution set then is the coordinate point 8 and 12. Parentheses there tell me in this context it's a coordinate point. Sometimes I'll put it in set builder notation, which will put the set builder parentheses around it as well. So when we're using the addition method, sometimes we have to modify through our usage of algebra one of the equations or both of the equations such that a variable would be eliminated. And that will help us take a 2x2 system and turn it into a 1x1 system. 1x1 system is easily solved.